Okay, so we're going to find the point or points where the tangent to this cubic here at this point meets the curve again. So you've got a cubic, so just visualize a cubic. So let's say I've got something like this. Alright, and let's just say I've got a tangent at a point. See how the tangent can meet that cubic again at another point? Okay, so you get the tangent meeting the cubic at two different points. Okay, alright, so how would I do this? Alright, so my function is a cubic. It is x cubed plus x plus 2. Alright, now I've already got the coordinates of the point at which it meets. Usually we're just given the x coordinate, aren't we? But here we've got the x and the y, so I don't need to sub in to find the y. So I already know the coordinates, so I can go straight to finding the derivative. Okay, the derivative of this would be 3x squared plus 1. Okay? Alright, now this is the slope function for the tangent, okay, at this point. Alright, so what I would say, so when x is 1, the slope of the tangent is 3 times 1 is 4, okay? So at this point here, the slope of the tangent is 4. So then I can sub into my equation form here where I go, okay, the y take the y coordinate, which is 4, over x take the x coordinate, which is 1, is equal to the slope of the tangent. Okay, so this is how I get the equation of the tangent. I'm trying to get the equation of the tangent. Okay, so rearrange this, so it's y take 4 equals 4 bracket x take 1. Okay, so y take 4 equals 4x take 4. So y equals 4x. Y just equals 4x. Okay, so that is the equation of the tangent. Okay, so I've just, as we've been doing in past examples, I get the derivative, I find the slope, so that's the slope function, I find the slope of the tangent, I then use that to get, and the coordinates to get the equation of the tangent. Okay, so we want to know where the tangent at this point meets the curve again. Alright, so where it meets the curve again, okay, it is equal to the curve, isn't it? So at this point here, the equation of this line is equal to the equation of that curve. Just there, they're equal to each other, just there, they're equal to each other. So simultaneous equations. So I would say this cubic, x cubed plus x plus 2 is equal to the equation of the tangent, which is 4x. So the points at which they meet, they are equal to each other. Okay, so I've got simultaneous equations here. Now if you think back to simultaneous equations, a way I can solve this is, okay, I can make it equal to 0 and therefore find its roots or find its solutions, and that is actually finding the points at which it meets. Okay, so if I made x cubed plus x plus 2 take 4x equal to 0, okay, let's neaten it up. So that is x cubed take 3x plus 2 is equal to 0. Okay, so what I've got here is the solutions of this cubic, okay, so the roots of this cubic, where this cubic crosses what we now call the x-axis, is actually the points at which these two meet. Okay, so the zeros, you can call it, roots, solutions, whatever, the zeros of this cubic are the points at which these two meet. Okay, so I know from the start of the question, I want to find where the tangent to this at this point meets the curve again. So I know at least the tangent meets at this point. So that's one of the solutions, isn't it? And a tangent is where the curve touches it. It doesn't cross it. Okay, so I know it's got a repeated 0. Okay, a repeated 0. So I know, in order to factor this, I know there's a repeated 0 at 1, and obviously I put negative 1. Okay, so and why am I squaring? Because it's repeated. You guys should know that. Repeated roots, squared roots. Okay, so I know it's a repeated root at 1, so I know that's the first part of this, factorizing it. Okay, then I think, alright, so how do I make, if this would come out to x squared minus 2x plus 1, wouldn't it? How would I get an x cubed? Well, this that gives me an x squared has to be multiplied by another x. That gets me the x cubed. And then how would I get 2 here? Because this turns out to be negative 1 times negative 1, which is positive 1. So 1 times 2 gets me the 2 here. Okay, so I use the fact that I know that a repeated root of 1 is this, and then I look at this and I think, how do I get these here? And I go, so that must be it there. So there you go, I've factorized the cubic. Okay, and that says to me, okay, so therefore, all right, x equals 1, which that's what it's telling me here, or x equals negative 2. Okay, so it's at these points that the tangent meets the curve again. It's the roots of this cubic, but it's actually also at these points that the tangent meets the curve again. So I know the solution to, I know the y coordinate here, it's 1 and 4. How do I get the y coordinate there? I'll just go onto another piece of paper. So I know that it meets it at x equals 1 and x equals negative 2. Okay, so how do I find the y coordinate when x equals negative 2? I just sub it back into the original function. Okay, so it's going to be negative 2 cubed. What was the original function? Plus negative 2 plus 2. Okay, so that gives me negative 8, take 2 plus 2, so negative 8. Okay, so I know the tangent meets the curve. Tangent meets curve at 1 and 4, which we're given at the start of the question, and then at negative 2, negative 8. Okay, so I'll just put this back here so you can see what was done. Alright, so I get the derivative, I find the slope function, I find the slope of the tangent, I find the equation of the tangent. I then, once I've found the equation of the tangent, I make that equal to the equation of the curve. Alright, I then make it equal to 0, and therefore finding the roots of this cubic is the same as finding the point, as solving this simultaneous equation. Okay, so find the roots of the cubic, which were 1 and negative 2. Then, once I've found the roots, 1 and negative 2, I already know 1 and 4 is a point at which it meets, and I already know, and then I've sub in negative 2 into the original function to get negative 8 to get the other point. So the tangent meets the curve here and here. So it'd be something like that. Okay, those 2 points.